For this presentation, our topic is application of heat transfer principle in food industrial equipment, and we have selected the boiler as our equipment. Boilers are very commonly used in the food industry for processes that require steam, such as sterilization, cooking, pasteurization, and drying. Now, I will pass to Farah to describe the boiler in more detail.
Our boiler cannot be turned on, so I'll be explaining it without turning it on. A boiler is a closed pressure vessel designed to convert water into steam by using heat energy from full combustion. The purpose of the boiler is to produce steam efficiently with controlled temperature and pressure for various unit operation in food processing. The working principle starts when fuels such as natural gas, diesel or biomass is burned inside the furnace of the boiler. This combustion produces high temperature flue gases. These hot gases transfer heat to the metal boiler tubes and shell. Water is continuously fed inside the tubes or shell, and as the metal surfaces gain heat, the heat is transferred into the water, causing it to boil and eventually become saturated steam. The steam is then distributed to equipment like heat exchangers, kettles, ovens, evaporators, and sterilizers. Typical operating parameters of industrial boilers used in food plants include temperatures around 180 Celsius to 320 Celsius and operating pressures between 5 to 30 bar depending on the boiler's capacity and process requirement. These parameters are controlled to maintain stable and safe steam generation while preventing thermal stress on the equipment. In short, the boiler changes chemical energy in the food into thermal energy in steam, which is then used as a heat source in many food production steps.
The next step.
In a boiler, all three modes of heat transfer occur together and each one plays a very important role. Conduction takes place when heat moves through the solid metal walls of the boiler tubes. The flame and hot gases heat up to the outer surface and the metal conduct this heat through the water inside. Conduction is influenced by the thickness of the tube and the thermal conductivity of the metal. Convection happens both in the hot gas side and in the water side. On the gas side, the hot combustion gases flow rapidly over the tube surfaces, which increase heat transfer rate. Inside the water side, natural circulation occurs because heated water becomes less and dense and rises. Circulation helps distribute heat more evenly and improve boiling efficiency. Radiation is dominant inside the furnace area. The flame produces thermal radiation which directly transfer heat to the surrounding surfaces like the water tubes and refractory walls without needing contact. Radiation is especially significant at high temperature flames and contribute as a large portion of heat transfer at the initial combustion zone. So overall, radiation transfer heat from the flame to the metal tubes, conduction transfer heat through the metal walls, and convection helps move and distribute the heat through both the gases and the water which speed up steam formation.
Later that same evening.
There are many factors that influence the heat transfer performance inside a boiler. A large temperature difference between the combustion gases and water increase the overall driving force for heat transfer. The type of metal used in tube is also important because material with higher thermal conductivity such as copper, alloy, and steel can transfer heat faster compared to lower conductivity materials. Surface area plays a major role because having more tube surface area increases contact between hot gases and metal surface, which boosts conduction and convection. However, falling or scale formation on the inner surface of the tubes can greatly reduce heat transfer efficiency because it acts as an insulating layer which blocks heat flow into the water. Using proper water treatment and regular cleaning helps reduce fouling issue. Insulation on the boiler walls prevent unwanted heat loss to the environment and keeps the energy focused on the steam production. When all these factors are properly controlled and optimized, the boiler can operate more efficiently and produce steam at a lower fuel cost with higher heat transfer effectiveness.
Understanding conduction, convection, and radiation inside a boiler allows engineers to improve the design, operation, and maintenance of the system. When heat transfer principles are applied effectively, steam can be produced faster, energy loss can be reduced, and fuel consumption can be minimized. This knowledge is very important, especially in food industry, where energy costs and product quality are highly depend on good heat transfer control. Thank you.